Hi guys, welcome to your channel DNA. So let's start with eBGP, iBGP configuration. In this scenario, we will focus on number 1, eBGP neighborship between the two routers via directly connected interface. Number 2, we will form eBGP neighborship via loopback to loopback or between the loopback to loopback interfaces, means indirectly connected, right? Indirectly connected. And number 3, iBGP neighborship between loopback to loopback. Here these three things we will test today over here. Okay, so first scenario, right? We have a router 1, we have a router 2, router 3, router 4 and total router 5. Router 1 belongs to AS65511, which is connected to the router 2, and router 2 belongs to the 65513. It means here we have to configure the eBGP neighborship. Why? Because both router belongs to the different AS. Now you have two choice to configure the eBGP neighborship between the R1 and R2 via loopback to loopback interface or between the directly connected interface, right? So I would go with the option directly connected between the R1 and the R2. So for R1, neighbor is 100.64.1.2 and for R2 the neighbor is 100.64.1.1. okay, this is the first scenario. In the second scenario, what we will do here, R2 and R4 both belongs to the same AS number, it means they will form the iBGP neighborship. So here between the R2 and R4 we will configure the BGP between the loopback to loopback, but we make sure these two loopback addresses should be reachable from the both the router. This R3 will only provide the routing service between the R2 and R4. I will tell you what are the challenges if you have a router in between two iBGP neighbor and we do not have any BGP neighborship. So what are the challenges? I will tell you later. Now R4 is connected to the R5, right? R5 belongs to the different AS65513. It means here we have to configure the eBGP neighborship. But this time we will configure the eBGP between the R4 loopback interface and the R5 loopback interface, loopback to loopback neighborship. So guys, please refer part 1, right, where I have explained in detail how to configure concept of the directly connected eBGP neighbor and indirectly connected eBGP neighbor, where I had discussed about the updates of loopback 0 and eBGP multi-hop command as well. So let's move and configure the BGP. So before go there, guys, two things here we have to follow. Number 1, right? Number 1, you have to have required a iBGP protocol in between, right, R2, R3 and R4, or here you can use a static routing, I can say static routing. Why? Because when this R2 will form a BGP with the R4, this loopback address 4.4.4 should be reachable via R2. Clear? Perfect. So let's move on. So now I have access to the R1. So let's first test whether R1 is properly configured or not. Go to the enable prompt, then show IP INT brief. Yes, I have connectivity between the R1 and R2, right? So what is the IP address of the R2? 100.64.1.2. Perfectly fine. So ping 100.64.1.2. you have to, right, before configure the BGP, you should able to ping the neighbor IP address. Okay, so let's go and configure the R1. Configuration terminal route router BGP 65511. This is my AS number, correct? Then I have to define the router ID. By default it will take 1.1.1 as a router. BGP router ID command is BGP ROUTR router ID, BGP router ID 1.1.1.1. Anyway, right, if you see, basically 1.11 was, there is a no manual configuration we have done. So next step is the select the loopback IP address, available loopback address as a router ID, correct. Then define the neighbor and neighbor 100.64.1.2 and mention the remote AS, right. What is the remote AS? So the remote AS of R2 is 65512, 65512. Okay, perfect. No need to configure anything else now. Go ahead and just save the configuration. Show IP BGP summary. No, we do not have any neighbor, right. I can see, right, I can see the configuration over here. See, 100.64.1.2 I can see as a neighbor, but it's still showing the idle. Why idle? Because one way only I have configured the BGP. BGP is a dynamic routing protocol, but here in the BGP you have to configure the BGP neighbor manually. It will not get automatically discover like OSPF and eIGRP discovering the neighbor. So we have to go and configure the R2. So where is my R2? Let's go and configure the R2. Here you go. This is my R2 router. Then enable configuration terminal, router BGP, right, 65512. Then define the BGP router ID, BGP router ID 2.2.2.2, right, and neighbor, define the IP address of the router 1. Define the IP address of the router 1. Here you have router 1 IP address. Okay, so router neighbor 100.64.1.1, and what's the remote AS of the router 1, which we have configured, remote AS 65511. Clear? Okay, so just wait for 2 minutes, right. You will get a pop-up where it will show you the BGP neighbor is up. Yes, absolutely correct. Here you go, guys, right. So here you can see the neighbor is up now. Neighbor is up now. So the neighborship between the R1 and R2 is a eBGP neighborship. Why? Because my AS number is 65512 and my neighbor 100.64.1.1 neighbor AS is 65511. It means these two are my eBGP neighbor. Clear? Right? Okay, let's move on. Then look for a configuration. Show IP BGP summary. Yes, you can see, right, you can see, guys, over here I can see the uptime 42 minutes, right, uptime 49 minutes now, 49 seconds now, right. So currently I have not yet sent any prefix to the my eBGP neighbor, right, or I have not yet received any prefix from the my eBGP neighbor. Here R1 is our eBGP neighbor. Route addressment we'll see later. So this is the simple way to configure the eBGP neighborship. So now let's go and configure the BGP neighborship. Let's go and configure the BGP neighborship between the R4 and R5 over the loopback to loopback interface. So before configure the BGP session, guys, you have to configure the routing, right, routing between the R4 and R5. Why? When you configure the statement neighbor 4.4.4.4 from R5, right, your 4.4.4.4 IP should be reachable. Okay, so let's go and configure the routing between the R4 and R5 before configure the BGP neighborship. Where is my R4? Yes, I do have a R4 over here. Enter, enable, then configure the routing, configuration terminal, IP route 5.5.5.5, which is the R5 IP address, which is belongs to different AS 255.255.255.255. And what will be the next stop, guys, over here? What will be my next stop address? Of course, I am adding a static route on R4, right? So for me, the next stop address will be the 100.64.1.6, and when I will add a static route in R5, right, for network 4.4.4.4, so my next stop is the 100.64.1.5. Clear? Right? Okay, so let's move on. R4, go to the R4. Yes, add and 100.64. 1.6 is the next hop address, okay. Enter. Yes. So first do one thing, let's first complete the routing between the R4 and R5. Where is my R5? I have, yeah, here is my R5. So enter, enable configuration terminal. You have to add a static route. For 4.4.4.4 IP, 255.255.255.255, and the next hop is R4 public interface IP address 100.64.1.5. correct. Enter. Then let's go and check the connectivity between the R4 and R5. How do we check? Ping 4.4.4.4. yes, 4.4.4 is reachable, but what will happen over here now currently when you are trying to ping, right, 4.4.4.4 from this router 1. So your destination IP address is 4.4.1 and your source IP address is a exit interface IP address which is 100.64.1.4. So you have to use a extended ping command where your destination is 4.4.4 and you will mention the 5.5.5 as a source IP address, SRC, source IP address. Clear? Let's move on. Where is my R5 now? From R5, same IP address. Then define the source. The source is my loopback interface, or you can define the IP address, or yes, loopback 0. See, I am now able to ping the IP address. How? See, now when I use a loopback 0 command, 4.4.4 is my destination IP address and my source IP is loopback 0. See here, source from 5.5.5 to the destination 4.4.4.4. This is how you have to check before configure the BGP neighborship between the loopback to loopback interfaces. Clear? So let's move on. Now R5, on the R5, let's configure the BGP neighborship with the R4. Configuration terminal, router router BGP 65513, which is the BGP AS of the R5, right? Then enter BGP router ID. Of course, by default it will take a loopback interface address as a router ID. 5.5.5, and then define the neighbor 4.4.4.4 and remote AS 65512. That's it. So let's first configure the simple neighbor statement between the R5 and R4, like we had configured between the R1 and R2. But R1 and R2, we configure the neighbor via directly connected interface. Neighbor IP address is a directly connected. Here, neighbor IP address is indirectly connected, right, which is behind the R4. So go to the R4, and there you can configure the configuration terminal, router BGP 65512, then BGP router ID 4.4.4.4, then define the neighbor 5.5.5.5, which is the R5 loopback interface, and define the remote AS number, remote AS 65513. Okay, so you can wait for 1 minute, 2 minutes, 3 minutes, 5 minutes, 10 minutes, or entire day, your BGP will not come up, right? Even though these two neighbor IP address are reachable to each other, but your neighbor will not come up, right? I told you why it is so. Just refer my part 1 where I have clearly mentioned about this issue. So I will tell you the issue in the at the high level. When this R4 has initiated the BGP sync with the R5 address 5.5.5.5 as a neighbor, in that case your router 4 took the source IP address as the 100.64.1.5 when your R4 initiate the BBG neighborship with the R5, where you only provided the destination IP address as a neighbor address 5.5.5, but when R5 sent BGP packet to the R5, in this case your source IP of the BGP packet is a 100.64.1.5. When the packet receive on the R5, router 5 look at the source IP address 100.64.1.5. Is there any neighbor statement I have configured for 100.64.1.5? No, I do not have any statement for 1.5. I do have a statement for 4.4.4.4. So I am expecting the BGP sync packet from source 4.4.4.4. And vice versa, R4 is also expecting the BGP sync packet from the 5.5.5.5. Clear? So in this case, guys, you have to go and configure the update source command. Okay, so let's move on. Go to the R4, router 4, and here command is neighbor 5.5.5.5. Whenever this R4 initiate the BGP session with neighbor 5.5.4, always take the source IP address of the loopback interface, loopback 0 interface. The same you have to configure on the R5, right? Neighbor 4.4.4.4, then update source loopback 0. Perfectly fine. Still you can wait, right, for the BGP neighborship status, but again the problem is different. By default, eBGP neighborship should be the directly connected interface. You can configure over the loopback to loopback, but as per the recommendation, as a best practices, you have to configure BGP between the directly connected interface. Now what is happening over here, guys? Tell me what is happening over here. Over here, right, your BGP neighbor 4.4 for R5, 4.4.4 is not a directly connected, is a indirectly connected. So to reach the neighbor 4.4.4.4, your R5 will look at the routing table how to reach next neighbor 4.4.4.4. To reach the neighbor 4.4.4, we have a static route added in a routing table, and for that we have a next hop 100.64.1.5. So it means to reach 4.4.4, I have to first reach 100.64.1.5, and further 100.64.1.5 will reach to the loopback address. So it means eBGP is not a directly connected. eBGP is not directly connected, is a indirectly connected, means it is not one hop away, it is a two hop away, 1 and 2. So you have to configure the one additional command, which is the eBGP multi-hop command. Okay, so by default, when you configure the BGP between the two different AS, in this case its multi-hop value is a TTL usually 1, right? So 1 TTL value means my next hop is 100.64.1.5, right? As soon as I send packet to the BGP sync packet to the my router R4, it will reset to the 0. So there is a no TTL value available with me to reach the loopback IP interface. That is why you have to configure the eBGP multi-hop 2, means my eBGP neighbor 4.4.4 is 2 hop away, and similar way on a R4 my BGP neighbor 5.5.5 is 2 hop away. So let's go and quickly configure the eBGP multi-hop command on the both router. Okay, so still your neighbor is down. So command is neighbor 5.5.5.5 and eBGP multi-hop 2. Same command you have to configure on the R5, right, where you can configure R5 router BGP 65513 and neighbor 4.4.4.4, correct, and command is eBGP multi-hop 2. Now wait for a BGP neighborship. Definitely your neighborship will come up soon. So 2 command, yes, here you go, guys, right? So I can see now the neighborship between the R5 and R4. Clear, BGP neighborship is up. So 2 additional command, guys, we have added over here, right? Number 1, show run. So if you look at the BGP configuration, right, if you look at the BGP configuration, here you can see 2 command, additional command. 1, neighbor 4.4.4.4, it's a remote AS, that is something very common when we had configured the R1 and R2. Additional command, which is the eBGP multi-hop 2, and update source loopback 0. Now what happening over here? Because of this command, right, update source loopback 0, when your R5 initiate the packet, BGP packet, so your source destination IP is 4.4.4.4 and colon 179 port number, and source IP address is now, because of this command, your source IP address is 5.5.5.5 and maybe any dynamic port. Right now, this IP BGP sync packet, when received by the R4, simply R4 will look at its neighbor statement. In the R4 neighbor statement, we have configured R5 as a neighbor address. So R4 is expecting the BGP sync from the 5.5.5, right, and now it's received from the 5.5.5. So guys, make sure when you have a eBGP neighborship between the indirectly connected interface, in that case you have to enable these two commands, eBGP multi-hop and update source loopback 0. Clear now, right? But this eBGP multi-hop command is not applicable for the iBGP, right? When we will configure the iBGP between the loopback to loopback, so this loopback 4.4.4 is almost 3 hop away from the R2, but no, eBGP multi-hop command is only and only applicable for the eBGP neighborship. iBGP neighborship doesn't require this command, but yes, when you will establish a iBGP neighborship between the loopback to loopback, definitely you would require the update source loopback command. Perfectly fine. Okay, so stay tuned. I will release the next video where we will configure the iBGP neighborship between the loopback to loopback interface. Thank you so much. Bye bye. Take care.